So our next topic is the white box testing. White box testing is also known as structural based testing. Why? Because we for white box testing we know the system, we know the particular component, we know what is written inside, we know the data flow, we know the workflow, we know everything inside. That is, we know the structure of our module. So that is why it is called structural based testing, and even sometime it is also known as glass box testing. This name is not that famous, but actually it is being used in the industry sometime. So what is white box testing actually? The white box testing drive tests based on the system internal structure or implementation. Internal structure may include code, architecture, workflow, data flow within the system. For white box testing, your work product, as I told you, work product is anything which you have, and based on that you do testing. It could be your requirements, your code, your software requirement specifications, your epics, your user stories, everything is our product. So for white box testing, we not only have the code as a work product. Normally in the white box testing we also check the workflow, as it is mentioned here. We see the architecture, we see the code, we know the code inside the code, we know the data flow. So everything we check during the white box testing. And as it is structural based testing, so sometimes we also have structural coverage, like how many decisions we have inside the code, how many data flows we have inside the code, how the data is flowing, and how many loops, or like you know the code, so you perform different kind of coverages. This we will see in the next paragraphs. The thoroughness of white box testing can be measured through structural coverage. Structural coverage is the extent to which some type of structured element has been exercised by the test and is expressed as a percentage of type element being covered. Like you have some some well-defined structured element inside your code, and then you say that because you know the code, it's a white box testing, you say that these paths are being covered, these structures are being covered, so this is the percentage of my white box testing. At the component testing level, code coverage is based on the percentage of component code that has been tested and may be measured in terms of different aspects of code coverage items, such as percentage of executable statement tested in the component, or the percentage of decision outcome tested. Like on the component level, as we have discussed, the component testing is normally being performed by the developer itself. So on the component level, what we care about, we care that there are, for example, 10 statements inside the code. We know the code because it's a white box testing. We say if all the statements are tested at 10 out of 10, so 100% statement coverage. Then we say that there are one decision, if and else. Like there is a if path, there is a else path. If we cover both the path, we know there are two decision outcomes, so then it will be 100% decision coverage. Normally for white box testing we have different kind of coverage. For to see if all the lines of code are covered, it's called statement coverage. If all the decision outcomes are being covered, called decision coverage. We have multi decision coverage, different type of coverages, but it's not relevant to the foundation level. So you only need to know, you need to be sure. Sometimes it's very critical to have 100% code coverage, or you can say statement coverage. The code should go through all the statements, the code should go through all the decision outcomes at least once. If for one time it go to the if part, second time it should go to the else part as well. So sometimes it's very critical. These types of coverage are collectively called code coverage, like all of them: statement coverage, your decision coverage, your multi-decision coverage, your functional coverage. So these are called as a total term as a code coverage. At the component integration testing, white box testing may be based on the architecture of the system, like you know the interfaces between components. And structural coverage may be measured in terms of the percentage of interfaces exercised by the test. So if you are performing on the component level, you should be very sure that all of the statements are covered, all of the decision outputs are covered. If you are performing white box testing on an integration level, you should be sure that all the interfaces or all the communication interfaces between the different systems or modules are being covered. White box test design and execution may involve special skills or knowledge, such as the way the code is built, how the data is stored. Like you need to know about the data flow, like to evaluate possible database queries, and how to use coverage tool and to correct interpret their results. Like as we have discussed that for the white box testing, you should know what is structure of the code, how it is developed. You should know the workflow, the data flow within the system. It's very critical. There is a very like a tip for you. Normally the white box testing technique, I will write it here, WBT, is widely used, or you can say is best for on the component level. Like you know the whole component or module or unit, how many lines of code are there, and blah blah everything. But if you are going to do this testing on the system level, then highly prefer is black box testing. This we will also see in upcoming videos. On the system level or on a system integration level, you should perform the black box testing, because over there you have some fixed requirements from the customer. You don't know what is inside this system, what is inside this black box. Then you perform the testing. So it is the white box testing. Then our next topic is change related testing.